I welcome Alex Cordovil. He's the Global Channel Development Director for Vertiv. And well, he's going to discuss a bit on the same vertical on the challenges front on the AI's energy appetite. Basically, what do we do with the power, with the cooling of AI systems and sustenance of that? As you see, there's a flow in the room. But meanwhile, don't let the energy down, please. A round of applause for the speaker. All of you, thank you.
Thank you.
We can hear you through the headphones. If
Yeah.
you want to hear yourself in questions, use
Sure. Thanks, everyone. Welcome to be here. Going to be talking a bit about a very different topic, which I appreciate. There's a lot of people that are still sitting down because we could not be farther apart in the AI stack from the data model to all the way the power infrastructure behind it. But it's interesting to see that a lot of you guys, modelers, are also concerned about power consumption and how we're going to solve some of these key challenges that we're facing. Look, we're not going to sugarcoat. We know that AI has been receiving a lot of media attention about the power and, of course, a lot about the sustainability challenges that it's bringing to companies, cloud providers, enterprise. They're starting to deploy AI out there. It is totally normal to see this kind of reaction. I'm not going to compare to a lot of what's happened in the past, but when computers was first introduced before the dot-com bubble, very similar headlines appear out there. So, of course, the media has a tendency to be a bit alarmist about new technologies. I think there is some credit to it on probably, are we exaggerating? Are we thinking? Are we not taking into account new technologies that are going to pop up and, of course, support AI to be more and more efficient and more sustainable? Of course, we don't know all of those that are coming yet. But there is a lot of concern to be had. When we look at the compute side on the efficiencies that we're seeing on the chip manufacturing, on the modeling, it is just outstanding. It's very hard to conciliate this idea of AI being a power consumer and a power hog when you look at the latest chip efficiency that we see. For the same compute, for the same token generation, for the same kind of compute requirements, we're seeing orders of magnitude of the amount of compute per watt that we have. So a lot of great news and a lot of great progress has been done on the infrastructure side of AI, and of course we expect this to continue. The challenge, of course, is AI as a technology is only increasing its adoption. So here we have this paradox of it is getting more and more efficient, yet we still see more and more power consumption by AI. Of course, this is driven by our models that are getting more and more sophisticated. In the latest Meta earnings call, Mark Zuckerberg announced that the next generation of Llama is expected to consume 10 times the compute that the current generation has taken to train the model. So this curve is not going to go anywhere. We love the support that sophisticated models can provide us. Of course, a lot of smaller language models, a lot of more efficient models are coming up. But on this frontier side, it's going to continue growing in terms of compute and data requirements. The big driver for AI power consumption, however, is going to be on the right-hand side. It's the adoption. We're seeing enterprise taking these use cases and really expanding this at a very steep rate. Use cases that were seen in 2-3% of companies out there. The projection is in 6 months' time to be employed by 30% of enterprise out there. So again, the acceleration of deployment and adoption, it is just outstanding and driving a lot of power consumption, especially moving from more and more training to more and more inference. It is going to be very hard to equate bring AI compared to tasks that we're already performing. I think there are some very interesting studies that compare what AI is consuming in terms of power versus what a human would consume in terms of power. So when you compare what ChatGPT needs to generate, here is a 250-word page document of a Word document. A same person, if they're sitting in front of the laptop, needs to write down a page, that's going to take some 40 minutes of time. That's the average of typing that people take. So that, of course, consumes energy as well. So how can we equate a task that is totally outside of the AI perimeter in the edge in a person's laptop to a task that is being performed, of course, more efficiently at a data center? I think it's going to be a very interesting discussion that we're going to be seeing. It's very hard to measure, of course, because it's hard to isolate these tasks and compare apples to apples. When we look at data centers themselves and AI loads in the data centers, what we're seeing, and we're seeing this in our business, is a demand that is skyrocketing. We are seeing projections of data center demand, power demand, to double in a few years' time. A lot of it's driven by AI. You can see on this table of AI being the little purple part on top that was a small part of data center capacity. It's going to end up, by the end of the decade, expected to be half of entire data center capacity to be allocated to AI workloads. We are not alone. Data centers are, of course, bringing in and asking a lot of more power. This is part of a bigger trend. Electrification is here and is here to stay, and it is putting a lot of pressure on the power grids. Data centers are around 40% of the entire, let's say, additional capacity that we need from the grid these days. Of course, a lot of people are saying, oh, AI is to blame for a lot of it. We're not talking about electrical vehicles or other technologies in the same shade, because we see them as much more positive impact in terms of carbon footprint, and of course they don't get a lot of the slack that, or a lot of the blame that AI can get. Electrification is helping us to put pressure on utilities and power grids and governments to adjust and invest on their grids to make sure that we're transformed for the future. At the end, we are all suffering from a very similar topic, which is it all depends on the energy source. So we're talking about carbon footprint, we're talking about sustainability. When we look at the US grid supporting electric vehicles charging, more than half of it is being charged by electricity that was generated by fossil fuels. So how good is that? Of course, there's still great benefits in moving to electrical vehicles, but it's really fundamental for us to act on the grids that is supporting these applications to make sure that we're ready for the future. There's like earlier, I think a month ago, there was this big wasn't really fake news, but a lot of discussion on the news about this Tesla charger that is just next to a diesel generator. These diesel generators, they are much more to provide power backup than the primary power for that kind of charging station. But it's really jarring for someone that's charging their electrical vehicle and see a diesel generator just next to it being going into the charging station. So I think we're going to be really working and attentive to understand how governments and utilities are working towards solving this conundrum in the power grid, because at the end, we've been talking a lot through this conference about AI use cases, some of them positive, some of them problematic, that we're going to need, again, government action to support us regulate and curb those. But it's going to be very hard for us to say, look, AI is here and can bring new antibiotics molecules to the market that would take years to be discovered by scientists, and AI can support that in a few weeks or a few months' time. Are we going to say, no, AI, you're not going to have energy, you're not going to have power to do this kind of miraculous drug discoveries? So many use cases have a great societal impact, and I think it's going to be very, very challenging for us as society to say that we're not going to be able to apply technologies that can really change lives of millions of humans across the world because, of course, we don't have power to support these technologies. Government is, as we mentioned, government has a big role to play here. And we really working and supporting, understanding how government's going to act on that front. There is a lot of think tanks and government organizations trying to understand. European Union has doing a great job on EU directives. Germany has been doing a great job on telling data centers what the government's expecting data centers to be built, what codes they're expecting to be following to make sure that they are sustainable. And of course, this is only going to help the industry move faster to a goal that it's already being pursued for the last years. Of course, the other side of the coin is investment in the power grid. The power grid, the US power grid, that people call it the biggest machine in the world. This is often we see parts of the grids that are, of course, old and obsolete. These investments, the power grids that are coming now, are really welcome news for our industry, because without them, we're not going to be able to run our models, we're not going to be able to deploy our AI use cases out there. The good part is, as power is the biggest cost of any data center operator, we see that the data center industry has already been working towards efficiency in the last 20, 30 years. This is not news for the data center industry. We, of course, getting more government support and getting government push is going to help the industry to align and converge faster, but AI is really supporting us with more efficient cooling solutions. So we're going to be talking a bit about liquid cooling, which is really what really being propelled and being pushed by the need of AI, the new GPUs that have a very high thermal density, TDP, thermal design power, that really require liquid cooling, and guess what? Liquid cooling provides us a huge amount of efficiency benefits. Of course, AI supporting managing data centers, bringing in more efficiency in our power loads. Heat recovery, this is a huge topic that is getting more and more widespread. A lot of very interesting use cases or of tests already being deployed out there. It's really going to be understanding how we can really expand and scale up this kind of technology, and of course, a lot of government support is going to be required there. BESS solutions, dynamic power, microgrids, all this being supported, and again, AI is a big boost for us to go in this direction. Liquid cooling, for me, this is the great example of what liquid cooling can bring to us, and AI forced us to go to liquid cooling. So cooling tends to be 20 to 50% of a data center power consumption is on the cooling capacity. These chips get hot and we need to get the heat out of there. We know you have an air conditioner at home, you know that air conditioners can consume a lot of power. This is basically what's been happening. With liquid cooling, we have so much efficiency. Rather than having air pulling out all the heat from the chips, air is extremely inefficient as a thermal conductor. We need a lot of fan power, a lot of boom to drive that heat out of your chips. With liquid, we concentrate that into a much smaller amount of material that just needs much fewer pumping capacity to flow these liquids around your chips, and of course, providing a huge amount of efficiency. There are a lot of parameters to be taken into account when we compare one to the other. We see studies that are telling us that these efficiencies can go from 20 to 70%. Lenovo is advertising around 40%. We've done a study for data centers that get 20%. Equinix has done studies that are getting these liquid cooling efficiencies up to 60 to 70% of the cooling energy required. So this is huge in terms of benefits that, again, AI is bringing to our data centers that we can reuse here. We just had a talk by Google DeepMind. Of course, DeepMind, running their own Google data centers, is embedding AI in their management platforms. All these need to be synced up between your IT loads, what's running your compute, and of course, everything that is supporting it in terms of infrastructure. And again, providing huge gains in cooling system capacity or cooling system efficiency just by bringing those AI or machine learning algorithms to guide your cooling usage. We are doing this internally. I didn't have all the Vertiv numbers. We're doing embedding a lot of machine learning in, of course, our maintenance, but also our management systems. And this is really the way forward, that data centers are getting smarter and smarter to be managed to get to the efficiency level that, of course, our customers are pushing us to get to. Another huge benefit of liquid cooling is waste recovery. Heat is produced by the data center. If we can get the heat where we're being produced and send it to where it's needed, either houses, offices, greenhouses, industries, this is a super positive topic for our data centers. Basically, if you're just producing heat by a radiator in your house, an electric radiator, you're taking the electricity and just convert it 100% heat. Data centers, we take the electricity, we convert into a lot of intelligence, and heat comes out of it as a waste. Take that heat that already produced all the intelligence on our algorithms that is being needed by our customers, and send it somewhere with heat pumps, with domestic hot water usage. Again, this is really a very interesting direction where the industry is moving towards. Initially, Europe is really taking the lead with the push for sustainability that is here in Europe. We're already seeing a lot of applications in the US where sustainability tends to be more of a second topic in a lot of deployments as well. So really to understand, to see how important and how widespread this technology is moving towards, from homes to entire district heating, to now we see a very interesting example of fish farms and greenhouses that are being used heating from data centers. The swimming pool, the Olympic swimming pool training pools in Paris were fully heated with data center heating, heat waste. Take that heat, move somewhere where you need it, and all the power that you use for your data center, usually a lot of it is green power with power purchasing agreements from colo cloud operators. It's pure green electricity, green heat that is used for your other applications. So really, really great direction where the industry is converging to. We're going to see more and more of it, and of course, going to be a lot of it's going to be embedded in the credentials, in the sustainability credentials of our models and our infrastructure. Another interesting topic is, as data centers get bigger and bigger, we're now starting to see data centers to get to the hundreds of megawatts of capacity. Some data centers or some campuses really getting closer to the 1 gigawatt or surpassing that limit. Data centers become really energy buffers in your power grid, and they are not in conflict with your power grid operator or your utility. They can be a support for utility operator. So we see a lot in the power grid. This is a sketch from the power grid of California. Of course, very sunny place. Sun only shines during the day. A lot of green power available during the day. Guess what? To extend the availability of green power, we need huge batteries to extend that. The grid in California is already working with a lot of battery storage system applications that it can extend that, and data centers are playing a part in it. We're already working with companies. This is an example in the Nordics where companies that are really supporting the grid. So whenever the grid has a lot of sustainable power, the data center says, hey, I have battery capacity here. I'm going to take that solar, that wind power that is intermittent in its very nature and store for you, Mr. Grid Operator. In the night or whenever it's really cold and people are using their heaters a lot, we're going to take that down, and I'm going to supply power for you for the grid. So a lot of great stuff being here, data centers being part of the grid as microgrid operators that can support it with battery capacity. And then, of course, Vertiv is really enabling, supporting the enablement of data centers to operate as efficiently. This is one of our core directions whenever we support data center design and build. Efficiency is at the center of all our discussions. Of course, we have our own important commitments in everything that's responsible business to make sure that our carbon footprint, embedded carbon in our equipment is also communicated, and we can also work with our customers on that front. And that is it. We should have like maybe a minute for a question or two, maybe.
Before we go into one question, which will give you time for.
Yeah.
In the interest of time, again, any one question from the audience? All right, I see a few hands raised here. Somebody from the team will bring the mic to you, so we make sure that we hear you properly. So you are the selected one.
Yes.
Gentlemen, he's coming here this way. You may stand up, introduce yourself so people know you. We put extra pressure on you as well.
Thank you. You mentioned the use of heat waste recovery, specifically, for example, the use of it to heat the pools at the Olympics. To what extent do you see heat waste recovery, given that it's very inefficient over long distances, to what extent do you see it as more of a kind of CSR image improvement, or do you see it more of an actual long-term implementation solution?
That is exactly the challenge. I think here the topic is about understanding how government is going to help us put data centers close, especially with AI, data centers being closer to consumer markets, not only of data, but also of heat, is going to support a lot, because then we can plug in data centers into district heating solutions that really bring that efficiency to a much higher scale. So I think that's the limiting factor. That's why we see a few examples still, because we don't have someone that can consume the heat next to the data center facility as easily as it is. But as regulation comes in and forces data center, Germany is a great example of that. I think from 2030, 20% of heat needs to be reused in data centers. So they have very clear directives, and that's going to make the market move in this direction. Thanks,
right,
everyone. We're in the booth there. If anyone has any other questions, just in the main stage here, B72. Very happy to talk more and answer any other questions.
Big round of applause for Alex, please.
Thank you.